Hola, ¿cómo estás? Oh, no, Spanish. English, okay. I hope you guys enjoyed your lunch, and we're continuing our take on working with Git. Please welcome again our friend Lemi Orhan, who will be talking to us about Git anti-patterns.
Thank you. Thank you. Thank you. Hello again. It was, I guess, around 2009. I was working at Sony, and we had been using SVN for a long time. Who is using SVN now? Hello. Hello, people. So we had been using SVN, and we were not very happy about it at that time because every commit needed to be uploaded to a server, and due to the network issues, we had to wait a lot in front of the screen. And we really wanted, by ourselves, wanted to work at home or at a place where internet was absent or not available, but we could not commit because it needed to go to a server. So it's not a distributed version control system as Git. It's a centralized version control system where the whole code, whole branches, all tags, everything stays on a server. My technical leader introduced us Git. At that time, we didn't know the Git, of course, and I Googled, I searched, and noticed that noticed the name Linus Torvalds under the Git, the name. So, hey, if Linus has a name on something, it should be an interesting thing, right? So your expectations becomes higher, and then we decided to move Git. And in 1 week, we migrated 250 million lines of code to Git. And I was in a team that is responsible for that migration, and we were very excited because, hey, we were using a new tool, and Linus Torvalds has a name on it. By the way, after a few days, my friend just sitting in front of me shouted and swear, lots of curses I heard, I remember, because he said he lost code. Okay? He said, I couldn't find 3 days of my work. For the 3 days, he coded, he programmed, coded, and lost everything. And we searched a lot, but we couldn't find it because we really didn't know Git at that time a lot. And anyway, he rewrote everything from scratch, of course, faster than 3 days, however, without any motivation. At that time, I started to notice that Git is a very powerful tool. However, with that power, you may use in a wrong way. And throughout my career, I started to notice some patterns, some harmful patterns, what I called anti-patterns, that people really use it, fall into it regularly. Then I try to combine them into one talk, and I would like to describe you one by one, okay? But I should say the advices here worked for me, does not mean work for you. So all those are my advices that worked for me. Therefore, it's up to your dynamics, your code base, your style. So just take that into account first. Okay. So do you push every of your commit immediately after you create? So you commit and push, you commit and push, you commit and push. If you commit and push every single time, that I noticed many things, similar things in the past, you're doing something wrong because you fell into, it means you fell into an anti-pattern because if all you do is pushing your commits, then you are missing a big step while using Git. So Git is a version control system, and the main aim is versioning. However, you may do mistakes. Of course, you may do mistakes, and you have to handle those mistakes. If you push, after you create your commit, you miss to fix those problems. So if you push to a branch, it means you, from now on, you have to force push your fix to your branch. So force push, if it's a private, a topic branch, it's okay, because you are the only one who works on that branch. However, if it's a public branch, like master branch, develop branch, you might be in trouble, and you might mess the Git graph a lot. So, are you brave to jump on any of the commit in your commit graph? If I can answer this question, no, I'm not. Most of the time, when I look at the commit graph, I see lots of not completed yet commits. So those, so I really couldn't understand where a feature is completed. So like here, this is a real screenshot from a commit graph that I took years ago, and this is the feature my friend tries to complete, but it took time, you know. And which one is the last commit for the feature? The last one, the newest one? Or should I wait for a new commit to complete? So it seems you cannot really understand where a feature is completed, where you can see a fully working snapshot of your code base. So when you jump into it, so Git is a time machine. You can jump, you should be able to jump to any of your commit at any time, and when you jump on it, your code base should compile, your tests should run, pass, and it doesn't mean your features should be there totally 100%. However, your application should boot up even if it's if that is a desirable situation. So that is very important. So when you jump to any commit by closing your eyes, I want to go to that commit. So what we usually do is we jump to tags. So we tag usually, we put tags to it. We mention that this is the working snapshot. So this feature is ended right here. Now you can continue developing from now on. So this is an anti-pattern. We are using it in a wrong way, I believe. Also, long-living branches, they are safe, they are comfort balloons, so comfort bubbles. So long-living branches are there. Branching mechanism is very powerful mechanism in Git. I really love it. And you can do anything you want. I mean, anything you can do by branches, of course. However, going into a branch or creating a new branch is like going away from your home. If you come back to your home after 3 days, you most probably, you can see your wife, your home, your furniture, they're there. They're already there. However, after you come back 30 years later, most probably you cannot see your house, the house that you left. Even you might not see the people living there. So you have to go back to your source branch as fast as possible. So, but how we can do that? I will describe it later. So this is a screenshot that I took. This is a real screenshot, by the way, in a project. This is the highway pattern in Comet Graphs. So in Comet Graph, there are many patterns. More than 40 branches. They are waiting to be merged. But how? No one knows. But they are waiting. Someday, a year later, or someone really remembers that, hey, we had a branch. I remembered last year we created a branch. So then someone may decide to merge it back to the source branch. OK. Also, cherry pick. Interesting. Some companies really love cherry pick. They love the comment, cherry pick comment, because those companies built their release plan, release flow, by using their cherry pick comment. So they built release branches by picking one commit at a time. So I want to do a release to production, but before that, the architect, the ultimate guy, knows everything, sits in front of the screen, and opens the whole branches, and one by one, I want this feature, cherry pick to the release branch. This feature, oh, not this branch, I will skip it now. And one by one, the architect, I experienced that these guys use the cherry pick command and create a new release branch. However, cherry pick means conflicts, merge conflicts. Every cherry pick might, a merge conflict may happen. So resolving a conflict is not a tasty thing, as you may encounter an experience. So this is not the right approach. This is also an anti-pattern. So what should be the cure? Just a second, I will describe it. So I mentioned at the keynote yesterday that as developers, we are documenting a lot. And the commit messages, they are really important. Pull request messages, and even the commit graph itself is important, is a documentation. People look at the commit graph and tries to understand what's going on. And do we really understand something from the commit graph? Most of the time, when I open a commit graph on projects, I can understand nothing. So they are too complex. So this is a real screenshot. This is called the mountain pattern on the commit graph. And somehow the branches are merged or not. I couldn't understand. Tags merged, there are release branches, there are tracking branches everywhere. It's like a mess. There are lots of waste in the commit graph, and you cannot really understand what's going on. What really the author thought while designing this? So this is an anti-pattern. So if you see such diagrams, and if you cannot understand the commit graph, this is it means you fell into the anti-pattern. So what should be the cure? Of course, there are more than one way to handle all of these situations, but from my point of view, the philosophy should be commit early, commit often, perfect later, and publish once. This is a philosophy, and you can build your Git flow, Git branching mechanism from this philosophy. So how we can implement this philosophy in reality? It is easy to say, commit early, commit often, perfect later, publish once, but how? Let's jump on it. So our very first step is keeping your branches short. So I really love developing in TDD, I mean, in TDD way. Therefore, my loop is red-green refactor, and at every red-green refactor, after it's green, I commit. After refactor, I commit. I code, it's red, okay. After green, I commit. After refactor, I commit. So I always, so in TDD cycle, I make usually 2 commits. And so it's a master feature branch mechanism, you may call it. So first, keep your, so we have to remind that we should keep our branches short. And let's assume that from master branch, you create a new branch, what we call this a topic branch. So when you go into a branch, a topic branch, in most of the cases, you are away from the CI. It means any attempts to push to your code to your topic branch is not validated anymore. So continuous integration server validates your code base on your master branch, and if you go to a branch and a topic branch and you live in it, it means your CI server does not run, does not validate on it. So, but you can, of course, make some tricks and make it also validated. But anyway, so you do your commits. So one comment I can describe is git fetch origin master and master. What it does is simply synchronizes your source branch. So you are now on topic branch. So you are not on master, but your friends, they merged their features to master, and somehow you have to pull it. You have to get it to your local, and you have to merge it back to your topic branch. So how you can do? First, you have to synchronize your source branch. Here master branch is the source branch, so you have to either you check out to master branch, make a git pull, then go back to your topic branch, or in one command, you can run git fetch origin master and master. So what it does is it simply synchronizes your source branch. Then, what you need to do is a merge. A merge from master, from source branch to your topic branch. Okay. Cool. Now you might see a merge commit, which means a conflict might happen. So you have to resolve that conflict because your friends, the commits that your friends pushed may be in conflict with yours, so you have to resolve it. And you continue developing it. And you have to do that regularly. Git fetch origin merge, git merge master. Few times a day, maybe more. I mean, today I've been following these principles for years. What I'm doing is, I mean, whenever I remember, my friends might push something to the master branch because the pull request notifications arrives to my mobile phone, and when I see something is merged, then I run immediately git fetch origin master and master to get the code coming from master and merge it back to my feature branch. So that commit graph has a ladder pattern. So you see when you open the commit graph, you can see a kind of ladder in a horizontal way. So you do it regularly. Now what you need to do? Okay. First, check out the master and make a squash merge. What it means? I want to merge my topic branch, but I don't want a merge commit. I hate merge commits because they they are kind of waste in my commit graph. So what I need to do is I want to squash all the commits in my commit on my topic branch. Hey, I want to squash it into one, create a new commit, and put it to the master branch. First, check out the master, and squash it, and put it. Whoop, yep. Now, in that situation, in that time, you should see your topic branch there, and a new commit located at the top of your master branch with the content of all commits in your topic branch. So, this allows you commit early, commit often. Don't care commit messages if you are committing to your topic branch. You have to commit early. Whatever you want, commit it. Commit without any hesitation, no worries. You don't need to put any commit messages at all because you have the perfect later. Perfect later means you will squash them into one and create a new commit message. A new one, a better one. You take a deep breath because you squash them into one. Now your feature is over. It's done. What you need to do is you need to put it back to your master branch with a new, well-defined commit message which can fit the standards. Okay? Then you can delete your topic branch. Simply with a capital D, because lowercase d won't work, because Git cannot understand that that branch is merged. So there's no merge commit, or there's no connection between the source branch and the topic branch. Therefore, you delete by capital D. And here it is, the perfect, simplest commit graph you can ever see. I've been using this one for a long time. One aim is, the ultimate aim for a commit graph is simplicity. So whenever someone opens the commit graph, they should understand what's going on. And every commit here is a kind of working snapshot. So every commit identifies a new feature or a new bug fix. And whenever you check out to a commit, any commit to the graph, you expect a working snapshot. So theoretically, it's the best situation for me. So now what you have to do is, by the way, we haven't pushed yet. So push is an important comment. So I believe, if I'm a Git dictator, I would get money from every push. So like $1 for each push. Because if you push, it means someone, if there exists a problem on your code base, then you have to force push. And if you are not on a topic branch, then it means you are in big trouble because you messed up the master branch. One day, my friend just came to me that he pushed 15 commits immediately to the master branch, and people start to pull it, and he wanted to fix it, but he didn't know. What we could do is just use the git revert command, which creates an inverse commit that normalizes the inverse of the commits that you already pushed to make it back to the initial situation. But it means a 16th commit should go to master branch. So we should keep master branch as clean as possible. So normally, if you are using GitHub, GitLab, or Bitbucket, you can use it in a more efficient way. So this is a GitHub screenshot. Who uses GitHub in projects? Perfect. I use GitHub and GitLab at the same time for different projects. And at GitHub, on the settings side, you can see it on the merge button part, allow squash merging. If you click on it, at every merge request, git merge -- squash command will work. It squashes the commit in your branch and creates a pull request with that, with only one commit. So I advise to click on it. Or if you are using GitLab, who uses GitLab? Perfect. Okay. And on the GitLab side, the setting is a little bit different. While creating a pull request, there's a thing on the bottom. So it writes squash commits when merge request is accepted here. And also you can click remove the source branch when merge request is accepted, means after the merge, your topic branch will be deleted. So I advise to click on both. Okay. So I really love the idea of trunk-based development, and there are many ways to implement it. Commit early, commit often, perfect later, publish once is very crucial. Also, please use pull request. I've used Git without any hosting mechanism, without any pull request mechanism, like 5 years. You can do tons of mistakes. With GitLab, GitHub, Bitbucket, you can prevent your code base from doing mistakes at some point. Also, if you delete something, do not worry. If you delete your code base, your commits, don't worry. You cannot lose code at Git. Just one exception happens. I will describe it later on. Just there's one exception. Okay. Okay. So Git is a very powerful tool, but it's hard to really hard to learn the whole commands, right? Hard to master it, like Scrum. Scrum says it's it's easy to learn, but hard to master. It's the same for me to learn Git. So how I learned Git, I practiced on my local. I used the terminal heavily. Please use the terminal. Please do not stick on the UIs. So, I mean, I've been using it since 2009, and after 5 years, I went to one of my friends to solve his Git issue, and I asked, please add those changes to Git. And he said, what add means for Git? You've been using Git for 5 years and you haven't learned what git add means? Yes, because he always click on the commit button of the IDE, which adds everything, every changes, then commits. So in order to learn Git in details, I believe we should use the terminal. And also, you can practice in your local. So since Git is a centralized, a distributed version control system, you can, at the same time, you can keep your repository and the bare repository, that the upstream and the repository at the same time in your local, and do some practices on it. Okay? And I noticed something interesting. So what we usually do is we get all the changes on the code base, create a new commit with them, and push. But that commit contains bug fixes, features, refactorings, tons of stuff. So it contains everything that has changed till now. So what we should do, we should stop adding everything to the current commit. So there are a few ways to do it. One is if you are using JetBrains tools, many of you might use it. If you are using JetBrains tools, JetBrains is a local change set feature. So in that feature, you can, those three, they are the changes, and you can move it to a virtual name, virtual group. You can create a virtual group with it, and then you can create a new commit with that, from that virtual group. So that's a really easy way to create multiple commits from a change set, one change set. Also, if you're a kind of nerd and you love the black screen, the terminal, you can also use the partial add. Partial add is an awesome terminal Git command. You feel like you're sending a satellite to Mars at some point. So imagine, so when you git status, you see there are two changed files, but you want to add a chunk in a file. So git add readme. So in that readme, do you want to change it? Do you want to add it? No. Do you want to add these changes? Yes. So in a file, if you have two changes, you can select one of them and put it in a commit, and the other you can commit on another commit. You can add the changes to another commit. So that really improves your capability and make the commits understandable. So this is a real screenshot of commit messages. Turkish, English commit messages, bug fix. There's a bug fix commit, fix 2, or some refactoring 2. And who can understand what's going on? So in that commit, so we have to write good commit messages. Hopefully, that there was a very good presentation last hour, so you should have seen the best practices there. So my only humble advice would be using a template, a commit template. Commit template is an awesome feature for Git. So if you keep your commit template to your local, whenever you want to write git commit, the template opens, and you can add, by looking at the template, you can add your commits. It guides you. I really love. Okay? So, I have a question for you. Which of the following commands can cause duplicate commits in your commit graph? So, $100,000 question. So, the ones who says A, 3, 4, 5, 6. Okay, 6 A's, git rebase, duplicate commits. B, git push -- force. 1, 2, 3, 4, 5, 6, 7. I count you. And C, git merge. Git merge, 1, 2, 3. Okay. And git pull, D. No one. No one. Okay. Let me show you the answer. Yes. That's insane, isn't it? I mean, git pull, how come? that can happen, and I will directly show you how that can happen. Okay, first. Okay, so this is the upstream. This is the server. This is your local, and you have a fixed branch, a topic branch called fixed, and a master branch. And what you want to do is a rebase. Rebase is a reorganizing the base, changing the base of your topic branch. So let's rebase. Perfect. So when you rebase, your topic branch moves. So what you have to do is, since you already changed the history, you have to force push. So you pushed. Whoop. Yes, it means you push. Since you force push, so the topic branch moves on the remote. Okay. Then afterwards, your friend, your poor friend, doesn't know what happened. He thought everything is going well. However, you already force pushed your rebased branch. So in his local or in her local, this is the situation. In this upstream, this is the situation. And here run Git Pull. Git Pull is a combination of Git fetch plus Git merge. So when Git fetch starts, those commits just emerge on his local, okay? Then the second command starts, Git merge. Oh, baby, yes. That's a total mess. You see the same commit messages everywhere. Someone rebased his topic branch and pushed and force pushed without knowing you, without touching your shoulder. So what should we do? That happened few times. Then I learned why that's happening. So what we should do is, your friend or you should pull with rebase. Git pull -- rebase means if there is an historical change on the remote side, get it safely. Okay? That is important. So there is a Git configuration. You can change the main structure of your pool with this rebase. You can skip merge and use rebase by default. However, I really hate changing the default behaviors because I forget. I get used to it in my local, and when I go to my friend's computer, it becomes a total mess. So I really write the whole command one by one, character by character. Okay, there are more than this. So we saw many anti-patterns, but when I close my eyes, I could say many big fat commits, duplicate commits we mentioned. Evil merge. There's an evil merge. Who knows evil merge? Evil merge is an interesting thing. I have seconds, so I want to describe. So evil merge is this. So there is a merge conflict happens, okay? The merge conflict, you have to resolve it. So how you mention first I need to start how you notice an evil merge. So there is a bad line. So there's a bug happens, and you're searching for it, and you're tracing one commit at a time, one by one. You are looking at it. Who enters this line to the code base? And at some point, you come to a commit. The line is there, and on the previous commit, the line does not exist. So someone should put that line to the code base, okay? But it's a merge commit. So the parent A, parent B. So those parent commits should merge together. However, the parent contains a line, but the merge commit has that bad line, but both parents do not have this line. So someone someone intentionally or unintentionally writes that bad line during conflicting the merge, during fixing the conflicts in merge. So evil merge happens while solving the merge commits, so merge conflicts. So I had a story at the beginning. So what happened to my friend? Why he lost? So most probably he fell into the detached head state anti-pattern. So detached head state is a status where you are now on a tag, on a commit, not on a branch right now. So every of your commit is there on your commit graph without sticking to a branch. My poor friend worked 3 days without even imagining what would happen later on. Later on, he moved to master. He doesn't know that. He thought that that's okay, but then he lost everything. Then what we had to do? We had to do is git ref log. Git ref log is a log of movements of your head pointer, and one by one we should look at the head for the IDs, and we can see the last commit by looking at its content. Then we can create a new branch with that ID and make all the 3 days of work back again. And just hard reset, with the hard reset, you will lose your uncommitted code, or other than that, it is almost impossible to lose code in your code base. Thank you for listening. Thank you. I will be around if you have questions, if you want to have a chat about Git. I'm here. Also, she's there. We can do a chat, right?